Today we're going to build a 16-inch rigid Heddle Loom with 3D printed parts. Welcome to Hackaweek. Yeah, that's right, we're doing another loom today. So what started all this loom stuff in my life? Well, my wife Lisa, she's been bugging me to build a loom for the last like 2 years. So this year for Christmas, I bought her this little one that I found on Amazon. It's a little 2 Heddle loom, and it does a pretty good job of, putting together a little 6-inch wide thing. She's been making tons of scarves on this thing and loves it, absolutely loves it. But something a little bit bigger would be nice. So I found on Thingiverse this really cool loom. There's several, by the way, some Heddle looms that people have made. What I liked about this one is that it has 3D printed parts at the corners and the supports, but the main structure of the frame is made from readily available wooden dowels. So you don't have to print the whole frame, so it's a lot less time to print. I've already printed all the 3D parts. I did these this last week at my shop. I have the old Hicktop 3DP11 printer there, and I put it to work throughout the day while I was making money working on cars, printing out all these parts. So I'll show you a few of them here. This is the one that holds the heddles in place while you're working with them. This is one of the handles with the little ratchet gear on it. The heddles themselves, that's the part that the warp goes through, are printed out of PLA, this is PLA. This is PETG, which I'm really liking, by the way. It's really neat in that it's not that brittle. It can be flexible. It's a little tricky to print. You need to slow it down. If you go too fast, it gets really stringy. So I've learned a thing or two about that in the process. So we've got all these pieces here, and essentially, other than the 3D printed pieces, you just need to buy some number 6 by 1/2 inch wood screws, some wooden dowels. I think we have 7/8, 1/2 inch, and 7/16. And we're going to get started putting this thing together. There's really no instructions for this on Thingiverse. There are a couple of, there's pictures, of course, of finished products. There's a rendering of the finished product, and then there are some, photographs, like I said, of ones people have made. So I'm kind of working off the pictures, and part of the purpose of this video is to create a how-to that I can then send to the person that designed this. Maybe they'll post that video in the post on Thingiverse, and people will know how to build it by following along on this video. So first thing we need to decide is how big we're going to make this. That's the wonderful part about this loom, is it's flexible in its design. It's 16 inches wide, but you could make it 4 feet long if you wanted to, 2 feet long, whatever you like. Also, you can make it any width you like, because the way the heddles are printed in pieces, you can do 8 inches wide, or you could do 4 inches wide, you could do 16 inches wide. We're gonna go full 16, and that gives us the option of weaving something up to about probably 14 inches wide. I'm thinking maybe 16. Actually, it would be full width, 16, because that's the heddles. So we need to make it wider than that. The first thing we're gonna put together are the heddles. So here's the 4 heddle pieces. And by the way, these are 8 dent heddles. As I mentioned in the other video I did about the rug weaving loom, the holes where the warp goes through on these are called dents. Not sure where that term came from, but these are 8 dents. So there's 8 per inch. This is going to end up with 8 threads per inch. So we got all these together, and across this span, this measures 16 and about 16 and a half. The actual part of the heddles is 16 inches. So the first thing we have to do is insert a 1/2 inch dowel all the way through here and all the way through here. So we'll cut one to length at 16 and a half inches, another one at 16. Okay, there's our pieces cut. I'm going to chamfer the ends of these just a little bit so that they insert easier into the heddles. We have a little bit of a label here to peel off. That'll get in our way. Now we're ready to insert this into the heddles. Let's start with this one. Now this might be a little bit of a tight fit. It might just go right through. It depends on your 3D printer and how accurate things are. Initially I printed these with ABS, and I went with PLA because ABS has a tendency to warp and shrink sometimes, and they did indeed do that. And I ended up with holes that were kind of squished and oval. So after the first one printed, I decided that I was going to go with PLA instead. Get the other one in. See if we can just push this through like this. Maybe a little help with the hammer. I'm glad that this is a good tight fit. And I thank you for putting up with the video jumping around while I was pounding the hell out of the bench. Now we make sure everything is pushed together nice and tight. Now here, 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 and here are places for screws. You can see there's a nice little hole there with a nice taper, nice countersink. So hats off to the person who did this. Now we got to drill a little pilot hole, and we'll put screws in all 4 of those corners, and the heddle will be complete. I think this is a 3/32 drill bit. Anyway, we're going to drill a hole there, just so that it doesn't split and it's easier to get the screws started. Again, I'm going to make sure that this is pushed together really tight. Let's get 2 screws in there. Very nice. 2 more on the other side and we're done. Here is a picture of a rendering of the one that is on Thingiverse from user 1016, TEN161016. Nice job on that. Big shout out to 1016 for designing a really cool loom that's very configurable. You can make it, like I said, as long or wide as you wish. So that's what I'm going to go off from for the basic assembly of this whole thing. And here is a photograph of a finished one. So that gives you an idea what we're going to build here. So the first thing that we're going to do is put together, let's see, we're going to decide on the length. I've already done that, 30 inches from here to here. So the very first thing that has to happen is putting all of this together. So I'm going to cut 2 pieces 30 inches long for these edge rails. Then we're going to slide all of these bits on, and then once we get all that done, then we will fit the heddle into the holders, the uprights that hold the heddles. Then we can determine how long these pieces need to be and these pieces need to be. So first up, 30-inch pieces, let's cut them. 2 pieces 30 inches as before. Chamfer the ends a little bit for easier insertion into the plastic bits. Okay, looking at our picture again for reference, this one right here has a tiny little hole in it for the pin for the pawl to go on. So that one goes to the front, and then the other one on the other side does not have the ratchet assembly. It's just a regular upright. So let's get those pieces together. I want to show you something inside here if you can see it. Can you see in there the little stringy bits? Well, up on this side, that's because I printed this without support in the middle. I tried one with support. Let me see if I can find it. There it is. And that's nice, it gave me the support, but there's still little bits in there that need to be filed out, so I opted to not print it with support and just file all those pieces out. So that's what I've got to do first before I can shove this dowel through. I need to clean up the hole a bit with a rat tail file. Next up is the tension brace. It's got a hole here where a dowel goes that runs across this way. That's what holds the work up at a nice height, keeps tension on it. That's going to go about here. So So we got the one here with the pin in it for the ratchet. Tension brace is next. Let's put that on up to about here. We'll adjust all these better later. Now we've got one of the Heddle braces, and let me get these set up right. You can see they're mirror imaged of each other, and you want this part that's open to face toward the front of the loom. What happens with this is the lower position for the Heddle, and you take it out, go like this after you make a pass through and raise it up to the top. That changes the shed. We'll talk a little bit about that later. And then down here is the neutral position. So you want these openings facing toward the front of the loom. So this one, let's see, that's for the other side. This is the one I want for this side. Let's slide that on there. And again, just roughly in position. Now we're going to put on the back tension brace, same thing as this one right here. So that'll slide on to about there. Now at the back on the left side of the loom, again, as I'm facing it, left side, this is where the ratchets and the take-up knobs are going to go. This is where the other one goes. See how they are mirror imaged of each other? So that one will go back here. That goes on. We'll just flush it out with the end of the dowel. So that's one side. And we'll worry about position and everything later. But right now that's one side complete. So what'll happen here is one of these wheels will go on, and then these little pawls will go on, and then there's a little pin that goes in, but that's going to be for later. We need to assemble the other side now. Okay, let's put the right side together. Got the screws facing to the outside. Just like the other side, we put on the end block first. And we're going to put the tension support with the hole facing in. Okay, now we're ready to take these two pieces and set them up 16 inches apart. And I need to move the camera in a different position so you can watch this happen. Both sides done. Now we put the Heddle in on the Heddle support. And we want that to have just a little bit of play in there, but we can maybe take care of a bit of that later. But as long as it's able to move a little and it still catches on the support, that's what we're after. Now the next trick is to get the dowels in here on the tension braces, and I think that takes, yes, the 1/2 inch dowels. So gotta do a little measuring and a little bit of math here. So the first thing I want to do is measure right now the distance between the dowels at this point on the Heddle brace. So, and I need to be pretty precise on this, within at least a 1/16 of an inch. And I'm just going to sight down here by eye. And if anything, I'm going to go a little larger than what I think. So it's 17 inches and 3/16. I'm gonna write that down. Next measurement I'm after is the depth of the hole in the tension brace. So I'm going to get out my calipers here. I'm going to set them on inch. They usually work in millimeters, but this time we're doing it in inches. And I'm going to measure the depth of that hole with the depth gauge. 0.488. So 0.488 times 2, anyone? That would be 0.976, almost an inch. I would say let's just go ahead and call it an inch. So we just simply add 1 inch to 17 and 3/16, 18 and 3/16. That is the length of the 1/2 inch dowel that I need. So let's, oh, I'm going to mark that out right now. And like all the other dowels, a little chamfering so they go into the holes easier. And let's take a look at the fit. There's one. And 2. Okay, let's cut another one. Now before I go too much further, I want to get the distance between the end blocks and the tension brace the same all the way around. So let me just come up with a number here for that. I'm going to use the caliper and say, well, we can go about, I'd say 3 inches. Let's start there and see how that works out for everything. Let's just do a check here to see how even everything is. You can see this is off a little bit. These are just a little different. I think what I'm going to do now is work my way from one end to the other and install screws. So let's start with these 2 end blocks here. Let's drill some holes, pilot holes. Now let's check the other end. I'm just going to use a dowel to make sure these are parallel. Go down to the other end. This block needs to go that way just a little bit. Give it a little love tap. That looks good. Let's make sure those are still parallel. Yes, they are. Now I'm going to put screws in this end. All right. Now we're going to go back, flip it over again, and we're going to line up the tension braces. They should have been 3 inches from the end, and this one moved on me. I want those to be perfectly lined up. So once again, more screws. And same thing down here. Let's make sure that they're right at 3 inches as well. And lastly, the Heddle supports. They look good right where they are. We need to flip those over. There's 2 screws in each one of those. Now we can put the 1/2 inch dowels back in place on the tension brace. And now we can check to see how the Heddle fits. Let's see if our math worked out here okay. Nope. I actually am off by about 1/4 of an inch. How about that? I wonder how I made that error. Well, whatever. We're just going to cut 1/4 inch off each one of these. All right, 1/4 inch removed. Mistakes happen. It's going to be okay. go that way. Okay. Just a little bit of play back and forth. I could probably shave off another 1/16 of an inch. And I think I will. Oh, there we go. Just right. Just a little bit of play. That's good. That's what I want. Okay, now we can move on to these pieces. So what's got to happen first here is I need to put the pieces in that go from this knob to the other side. And if you look over here, it attaches to that part with the 3 holes in it. So we'll stack up this piece and the retaining ring up against this brace and measure how long everything is here. If it's a little longer and we cut it a little bit longer, that's okay. It's not going to hurt a thing. 2 1/16 inches. These holes in the end need to be pretty loose. The piece needs to go in there and be able to rotate easily. So what I'm going to do is take a piece of sandpaper, some 80 grit, and roll it up and get it in there and see if I can just loosen this up a little. Shouldn't take much. That's what we want. Want it to be able to move easily. Now if you do that and it still doesn't fit, you can always sand the dowel just a little bit as well. Because we need that to rotate pretty freely. So just to keep things from moving around so much, I'm going to go ahead and put the screws in to this dowel. Definitely better. So let's take a retaining ring now, push it on, flush with the end, and put a screw in it. We'll push it through. And then this little piece on the wind-up section should just go on there nice. Look at that. Let's get a screw in there. And that moves nicely. Okay, so that moves easily, and there's a dowel that goes between here and the other side because there's another one of these on the other side. There are 2 dowels, in fact, and that distance is simply the distance between these 2 blocks. And we'll leave a little bit of room to make sure it's not going to be too long. So it looks like it's 16 7/8 inches. I need to cut 1, 2, 3, 4 of those. Yes, those fit nicely. So we need to take this back apart because we're going to have to put the dowels into the piece first and then load this dowel in onto it. So let's just put a dowel in here and another one in there. Flip the whole thing over. Get them parallel. And more screws. Ta-da! I've rotated this around now. This is the back of the loom, and there is a ratchet knob that goes on here, and the teeth need to point that way. That way it won't unwind until you lift up the pawl that will hold it in place. I'm going to take this piece of 7/8 dowel and shove it into there, and then push it through here. Let's see if I can determine how far that's got to go in. We need to do a bit of sanding on this one. Let's check the fit now. Much better. So over on this side, now I can take this piece and actually just hold it up to it like that and put a mark on it. And that's where I need to cut that piece. Now we can put this into the handle, push it through here, and there it is. That's where it needs to be. Now we're ready to put this piece on. Slide this into place, and we'll push that one through. And then we push this one through. And now we can drill holes, put screws. And there's a place on the handle to put a screw. It's recessed. And now we can actually put the pawl on there. I think they're both the same. Oops. Yes, so they go like this. There's a pin that holds them on. Put it through the pin. Whoops, slippery. And simply push the pin in. It's a nice little friction fit. There we go. See, it locks it up. Locks it up, allows it to turn this way. You flip it back. It's locked in place. I suppose if you wanted to get fancy, you could make a different one of these and put a spring on it, but it's kind of nice that you can just flip it like that. Gravity makes it drop straight down and it'll rotate. It's a nice design. Very well done. Now we're going to duplicate that whole assembly on the front side of the loom. We've got our piece here that goes in the handle. We'll go ahead and get all this together. And since you've seen this procedure before, we're just going to move on to it being installed. There we go. And now that one's got a pawl in it, and it's locked up. Now the next thing to do is go back and finish putting in screws all over the place. There's screws on the back of these that I didn't put in. There's screws outboard on the tension supports that need to go in. Several places where there are screws to go in. So I'm going to go back and do all that, and this thing will be assembled. And there it is, complete. All done. The 16-inch rigid Heddle Loom with 3D printed parts. A couple of notes of caution when you're tightening these up. Be really careful, don't over tighten them. The screws just need to be there to keep things in location. They don't need to be really tight. If you tighten them too much, this is pretty thin and it can split. Same thing with the retaining ring. Don't over tighten it, it will crack. I've got a couple of cracks in these, but they're not critical. They're going to work just fine like they are. Well, this certainly was a fun build, and I'd like to thank user 1016 on Thingiverse. I'm going to post a link to that page on Thingiverse where you can get the STL files down there in the video description. Also a link to the Hackaweek page on this project where all the details are there of the lengths of the dowels, what materials you will need, and what I printed everything at. Incidentally, this was PETG, printed at 235 on the hot end and 70 on the bed with a 20% infill. Some of the things I printed at 100% infill, like the retaining rings and the pieces that hold the take-up dowels in place, just for a little extra strength. You can also print these just at a draft quality or even lesser than that. They don't need to look pretty, they just need to be functional. So there you go. I hope this helps out people that are looking to build a loom and get into weaving. Weaving is awesome. It's a lot of fun. It's been around for thousands and thousands of years. It's one of the oldest crafts that humans do. So I encourage you to give it a try. There are also some simple little looms you can buy on Amazon if you want to get started, like the one I showed at the beginning of the video. So go out there and have fun with weaving. I hope you enjoyed this video, and don't forget to like, share, and subscribe. And until next time.